Mentally math!
Let's get mental!
Alright! Welcome back from spring break. Let's get to work.
Are we in 2 weeks?
Huh? We are recording, so let's stay focused on the subject matter at hand, please. So I'll give you a minute. You know, not me. You know the drill.
Yeah.
Okay. Okay, that probably should have given you enough time. Do you need help back there? No? Alright. I know that thing doesn't work very well. Alright, so remember that since we are multiplying our negative an even number of times, so we'll end up with a positive number. So 2 times 2 times 2 times 2.
Mr. Becker was right when he finished saying that. He was like, I knew it.
Be 16. And then for this one, we are basically doing -4 plus -4, right? Or -4 times 2. And then we'd say 4 times 4 is 16, but we're going to do this in scientific notation. So I'm adding a decimal.
Oh, Mr. Berger, can I move my desk behind Samir because it's
Yeah, do what you can. Yeah. I was concerned about putting you back there. So yes, move yourself to where it will work out. Then since I divided this by 10, I'm going to divide it by 10 one less time over here. So instead of -8, it's going to be -7. Then this is just 5w. 5 times w equals 60. So 60 divided by 5 is 12. So I got another way of looking at this, at the conversion to Fahrenheit. And so I'm going to, it is mental math, so I'm going to explain it first. But then I will show you what I'm talking about in case anyone got a bit bamboozled. Okay. Yes.
In the hotel, whenever I would set my fan, I would always calculate the temperature from Celsius to Fahrenheit. I was like, ooh, that will be like.
Right, so it came in handy while you were in Europe, huh?
I just like to do it for fun.
Okay, right on. Because yes, we are pretty much the only country in the world that uses Fahrenheit, so it comes in quite handy if you go anywhere else. All right, so that being said, so now since each unit of 10 is a unit of 18, right? So here's a new way we could look at this, is just keep the -30. But now you're going to have 3 sets of 8 to add to that, because it's 18 Fahrenheit for every 10 Celsius. So what you can do is you can think 30 plus 3 times 8, or 30 plus 54, or sorry, that's 30 plus, 24, which adds to 54. And then your last unit of 5 there, because 35, remember, 5 is half of 10, so 9 is half of 18, so add the 9, so 54 plus 9 is 63, and then remember that we, the base of 0 degrees Celsius is 32 degrees Fahrenheit. So essentially you need to find the difference between those two and slap a negative sign on it. So essentially 63 minus 32 is 31. Therefore, the answer is -31 degrees Fahrenheit.
Wow.
Okay, however, would you like me to show you what I just did?
Yeah.
Okay, let's do instant replay, but showing the numbers. Just mental math, I thought I'd show you, okay. So remember that the 30 equals, well, in fact, we could say the 35 equals 10 plus 10 plus 10 plus 5, right?
Yeah.
Okay, and that is, equivalent of 18 plus 18 plus 18 plus 9. Because 18, 5 is half of 10, so 9 is half of 18. Right?
Yeah.
Okay, we pretty good so far?
Okay.
And also we are thinking in terms of like these are all think of these all will be negative, but I don't think we need to worry about that right at the moment. But yeah, so negative, so I'm not going to bother doing that, right? That's not that helpful for visualizing this. Okay, now instead though, you could just think this is you can just say, well, what if I just brought down my 10 plus 10 plus 10, right? And I can just say that's 30, right? And so then that kind of leaves it 8 plus 8 plus 8. So you could just think of that as 30 times 3 times 8. Or 30 plus 3 times 8, right? So you can think of that as 30 plus 24, right? Which then can just get you to 54. And then you just need to take your 5 and add your 9 to get 63. Then, remember, you've got to subtract your 32. You gotta find the difference between these two, which is 31. And then at this point, since we have been dealing in negative numbers this entire time, we can just slap a negative sign on that. Say 31. Uh-oh. Whoops. Oh, well, that went sour. Okay. So 31 degrees. Negative 31 degrees Fahrenheit. How we feeling?
I have one thing.
Yep.
How you get 63? Couldn't you just do 18 plus 18 plus 18?
Oh, absolutely. It's been what I've been doing, but you can do a shortcut. You can just think of instead of thinking of it as 18 plus 18 plus 18, you can think of it as 32 plus 24 or 30 plus 24.
It's actually easier for me. I like doing the 18.
Okay, well, it's just kind of showing a different path to the same answer. Yes.
So if it's easier for us, can I just do the 18 plus 18?
Yes, you can. I was just showing a different way of thinking of it.
So all you have to do is 18 plus 18 plus 9 to find the answer?
Yeah, so really, okay, we can just go think like this. So okay, you can just think like this and just go, okay, 1836, 54, 63, and then subtract that from the 32.
Yeah.
Okay, if that's more intuitive. Okay, I'm just trying to show a little shortcut there, but
Good job.
Anyway, no, you don't need to do that. Okay, all right, so moving right along. 200% of 50, you're just multiplying that by 2 to get $100. Dollar bills. And then 100% more than 50 is just 50 plus 50 is $100. Okay, and then two triangles are similar if their corresponding sides are...
Oh,
Yeah. What's the word we're looking for?
Are the same.
Oh, one word. One word. Oh, yes. I'll do a pom pom if you can find it. This is not easy. Yes. No. Very, very close though. I mean, that's easily you could have thought it was that. Okay, yeah. No, not necessarily. Yes.
Equilateral?
No. Yes.
Identical.
No. Now they don't have to be the same size. They're just similar. Yes. No. No. Yes.
Proportional?
Thank you. Proportional.
Oh my god, it is.
There we go. Proportional. So essentially, you know, basically,
I was thinking of ratio.
okay, let's see. I want to make this one kind of okay. One more try. Just keep trying to make it equilateral. Hey.
Good triangle. Good triangle.
I'm okay, fine. All right. So basically, if this was like, if this was 2 and this is 4, you know, and this is no, I'm not even gonna try to make this 3 and this is 6 and let's say this is 4 and this is 8, right? Then all of these are twice as much as these, right? Therefore, since these are all proportional, then these triangles are similar.
Yeah.
Alrighty, I'm sure everyone's done the calculation here. So, square 10 minus 1 divided by 9 times 4 plus 1 divided by 9 times 10 minus 1 square root times 5 plus 1. Hey, what? Okay.
Yeah.
Plus 1 square root divided by 3 gets us to 2. Gets us to 2.
Yeah, get this 2.
Gets us to 2.
Get this 2.
All right, so now today we're doing another one of those where you really, for most of these, you know all the pieces to it, and I bet you can figure out, you know, kind of how to put that together to solve most of these, except for one where there is just a special rule to remember. Yeah, that one weird trick. And then the book has a couple of interesting strategies that I should probably get up in front of me here. Not with this one though. This one's pretty basic. Okay, so find the surface area. Surface area. So we're not worried about the volume, just the surface area. And so here I'll enlarge this so that we can look a little closer. So we want to know what is the surface area of all the sides combined on this. So see if you can, how much of this you can figure out without me. And one thing is for you to figure out what are the lengths of the sides that you can't see. They're on the other side. Right, what size do those have to be in order for any of this to make sense? So I'm going to give you a minute. Get out ahead of me. Yeah, there are a couple of kind of satisfying strategies here, and then they sort of seem to miss what should be a satisfying strategy. So I'm going to diverge a little bit from the book. Not this example though. This is pretty basic. Okay. So I think maybe a first thing to discern here is the lengths of the sides that we cannot see. Alright, so we can think that all those sides are there. So there, we now have a transparent triangular prism. Okay, so what do you think the length of this side has to be? Yes, sir.
4.
Yep. I'll just get that there. And then what would the length of this corner, I should say, need to be? Ooh, yeah? Yeah. Yeah. Okay, so that's 6. Okay, so we're going to do another deep breath and okay, so and there are a few there are some things you could do to probably save time on this, but also might make things a little bit confusing. For one thing, since there are 2 identical triangles there, you could just do 4 times 3 and not divide it by 2 because there are 2 sides.
Oh, that's what I.
However, I'm not going to do that because I don't want this. I want to be obvious what we're doing with the numbers here. And by the way, the number of people that did not divide by 2 on the test was a little bit alarming when you were getting the surface area of a triangle. Okay, so 6 squickums. So we got 6 squickums. Okay, so that'll take care of our 2 triangles. All right, and then and so then how about that rectangle? What do we need to multiply for that rectangle, do you think? Yeah.
We need to multiply for the bottom one?
The one that's based on the hypotenuse.
I think it's the 6 and 5.
Yes, you are correct. So basically that and that would be your sides for him, and so I will assume that people know that 6 times 5 is 30. All right.
Really?
No need to be smart, Alex. Okay. Okay, so I'm just going to put a squiggle on that to say we've taken care of that. All right, so then how about the bottom? I think this is going to start to get simpler here, right? How about the bottom? Yes.
6 and 3.
Yeah, those 2 guys. So 6 times 3 would be 18. Yeah, you might as well just call those out so it's not just me doing anything. Let me put a squiggle on him. And then I think we just have this back one left, right? So that one we would multiply. Yeah.
4 by 6.
Yep. Okay, 24. Okay, so I'll give a moment for people to wrap up. So basically 12. Would you like to do the honors of saying the answer?
Yes.
Who hasn't? Oh, you haven't. Yeah. 84.
Centimeters.
Yeah.
Squickometers.
Squickometers? No. At that point, we're just getting a little bit too obscure. Now, square centimeters, which we also call squickums to the people at home. Okay. All right. Yeah, that gets us to our answer there. All right. So this one kind of has one weird trick going on. Okay, so we've got a can of. What's that can of? Oh, it's soup, right? Okay, and so what it's asking here is what is the area of the label? That's part one. Second part is just what is the full surface area of the entire cylinder? But by the label they mean what is the surface area all the way around the cylinder? And how would you figure that out, right? And we are using 22/7 4 pi. So, now, here's the thing, is if we took the label off, and I know some people probably glancing in the book for it and know the answer here, but if we took the label off, what would we have? What shape would that be? Yes!
So the circumference would be the length of a rectangle?
Oh, that's not what I was asking. I was asking what shape would it be if I took the label off?
Rectangle.
Yes.
If you took what? No, you just stretch out the label.
Right? If I took the label off, that's what it would look like, right?
The circumference is the length.
And right?
Yeah, the sticker. I mean,
and we know that it's.
Wait, take what label It's just label.
Look, I wrote soup on it, okay? I mean, how am I supposed to be more obvious than that? Okay. Okay, so knowing that then, okay, so what you really wanted to explain how you get the length here.
So the circumference of the circle is the 7 we don't know that yet, but it's basically 7 times pi. But once you stretch it out, the circumference will become the length.
The circumference is the length, because that's the distance around it. Right? Oh well, you're I'm sure you're clapping for him and not me. Okay. And by the way, I'm already feeling like I owe you a couple of focus points. I'm just gonna spend the time going over there. Yeah. Huh? How is it a rectangle? Because if you took the label off, if you just peel the label off, huh? Because this is just wrapped around it. This is just wrapped around it. If you unwrapped it, it would be a rectangle. Is there any? Now it is been bent into the shape of a cylinder, but if you unbend it, there's no part of that that's bendy, that's curvy.
It's like the sticky parts.
Yeah. Let's see. Should I get the toilet?
Yeah,
oh wait, no.
Yes,
Got this.
do that.
All right. No, I've got these paper towels.
I told you it's a good idea. That's with it.
So here we have a roll of paper towels.
A soup cylinder.
Here's our cylinder, but if you unwrap it,
Oh, okay, that makes sense.
It's a rectangle.
it's a rectangle, sort of.
Well
Makes
said.
sense, right?
Well said.
Very nice. Okay, so
Stop. It's cylinder stuff.
okay, so that being said, so we have established that this is a rectangle, and the circumference is going to be the length of it. And so we're using 22/7 for pi because, oh, looky, it's a 7 centimeter diameter, right? So I'll give you a moment to figure out what is the length. One deep breath. But you know what we can do, right? A little bit of cross-canceling goodness. We can cross-cancel that, and we just have 22
I think that's my favorite
centimeters
thing
just chilling right there for us.
That's my favorite thing you've done.
That's good. I'm glad. Okay, so that gets our surface area of the label as 220 centimeters, 10 times 22. Okay, so we have A. So now the question is adding the top and the bottom, and the book actually calculates these individually and then adds them together, but I think that we can actually do a bit of a shortcut. But so could someone please remind me what is the formula that's going to get us the surface area of, say, one of these flat circular areas? Oh, yes, sir. Okay, so pi times the radius squared, or in this case, so pi being 22/7, then times, and so the radius. Now here's a neat trick though. So okay, the radius is half of the half of the diameter, right? But here's a trick. Is I kind of like this trick. So you could just describe that as 7 halves, right? Because 7 divided by 2, right?
Oh my god!
Right? Okay. So you can also describe that as times 7 halves times 7 halves, right? Right? Oh, what sorcery is this? No, you're embarrassing me. All right, so then you can do a little bit of
Cross-canceling.
okay, so we can eliminate these, we can eliminate this and get us to this. And so that essentially gets us to 77 halves.
Oh my god!
Right? Now, at which you could then, now the thing is that you could then actually play that out to 38.5, but I don't think that is really necessary because, and then what the book does is spoilers, they have you added up like, oh sorry, I've got my, I'm gonna erase this, don't worry, I know it's a little messy. They have you add this up like that, right? Because it is 220 square centimeters plus the 38 at the top, 38.5 at the top, and the 38.5 at the bottom, right? Right? So we do get that. However, I think that there's something we could do here instead. Okay, so we've got our 77 halves, right? But we're gonna multiply that by 2, right? So we could go times 2 over 1.
Oh my god!
Get it? Okay, you can clap on that, okay? Because I made that one up myself. Okay, so then that just gets us to 70 plus 77 square centimeters. Alright, getting us to I'll clear our space a little bit here. Okay, clear the field. Oh, not that much.
The soup! Dude, look what Samsung soup is.
Okay, so getting us to 297 square centimeters for the full surface area of the can of soup. All right. How are we feeling? Want to give me 1, 2, or 3? How's that? Okay, we good. Okay, right. It's just a lot of pieces to it, but it's all things you already know. Or could figure out, such as figuring out that the length has to be the circumference. You know how. Okay, Okay, it's okay. Do you have a question? Yeah.
Yes. What's going on?
What's going on?
Yes,
We were getting the surface area of the entire can of soup.
Then why do you multiply 77 over 2 by 2?
Oh, because there's a top and a bottom.
Oh.
Right? So we got it to 77 halves, right? And so what the book was doing was going, okay, well you can get that to 38 and 5/10, right? That is half of 77, right?
Yeah.
Okay, but then when they added it up here, they did this. Plus 35, then 2. And they added that all up to 297 square centimeters. But here's the thing: it seemed like essentially now you're gonna have to add these together or multiply this by 2, right? I mean, multiplication is repeated addition. So instead of saying 38.5 plus 38.5, you could just say. I mean, you could do it like this. There you go. You could do it like this if you wanted to. It's how the book did it, right? Just adding up your label, and then your top and your bottom. But just the way it kind of worked out with this, or well, I guess it would work out this way with any problem. I mean, you're essentially taking 77 halves and multiplying that by 2, right? So you can essentially just cross-cancel your way to just having that. Does that make sense? No? Okay, well, in the absence of that being a useful tool, you can just think of it like that.
Okay.
Just think of it like that. Just Yeah, you can forget my one weird trick I was trying to throw in there.
At
Okay.
some point, you're gonna have to add the 32.5, but you can do it earlier. So.
Yeah. So it's a way of saving a step. Okay, but you know, if that wasn't really intuitive to you, you can just say, okay, I'm gonna get the top and the bottom, add those to the surface area of the label of the rectangle that wraps around the cylinder, and just add it up like that. So if that works for you better, then that's totally fine. That's what the book said. Okay, so the next thing is we are going to be getting the surface area of a sphere, but I would like to show a more simple version of this. So at this point for this one, you're going to need to remember a formula. There's no other way to it. There's just a bit of memorization to this, of remembering what the rule is. But it's really interesting because pi is so weird, really. Okay, so let's see. And I'd kind of meant to get a picture of a sphere, so I'm just going to kind of try to fake a sphere for you. So let's say, I'm already off to a great start here. Okay, so there we've got that guy. And, I don't know, we'll maybe maybe, okay, so that, no, and then,
amazing on that cover.
sphere, alright? It's a sphere. It's a sphere. Okay, great. Looks kind of sort of like a sphere, right? Okay, great. Okay, we'll just leave it at that. All right. So, and this sphere. Whoops. Let me get a line here. This marble. Thank you. Well, it's actually going to end up being a rather large marble. Where I'm going to say that the diameter is 4
No, that's Earth.
centimeters. Now, it could be a little tiny model of the Earth that's 4 centimeters. Okay, that's about all the extra thought that we need on this. Okay, so getting the surface area of this. So, is what's interesting. So the formula here, and just for the purpose of just having a nice simple example, we are going to, for this one, we don't really need it that exact. We just kind of want to know a basic idea. So we're going to have, I'm going to use really wavy lines for this. We're going to have this be pi is approximately 3. Just for the purpose of us not getting bogged down in too many steps here. Okay, so the formula for getting the surface of the sphere is just 4 times pi times the radius squared. And now, we actually discovered you can just run this across. So, we can just say 4 times 3 times, and then of course our radius here, I meant to change it. Our radius here is 2 centimeters, right? So, and that squared is
4 centimeters squared.
And it actually works.
Yeah.
You can't just go left to right and get to the answer. Now, here's the thing though, is a way to think of this, to kind of try to remember it, is what you're doing is you are getting the surface area of, imagine there, well, actually wasn't that bad, but okay, imagine there is a flat 2-dimensional circle at the center of the sphere, right? That has an area. Okay, so essentially what you can think of this as, the area is 4 times, and then the area of our flat surface here is
12.
Yeah, is 3 times 4 centimeters. So this is the area of this.
Yeah.
right? And then the formula here is 4 times the surface area of that imaginary flat circle at the center of the sphere. 4 times that is the surface area of the outside of the sphere.
Oh.
It's kind of weird. Pi's weird. So
Why
essentially, is this getting a little mystifying? Okay, so imagine like at the middle there you can just imagine like so if there's a sphere,
Yeah.
that there, if you did a cross section of the very center of it and had a 2-dimensional circle and the surface area of that, just the formula is 4 times the surface area of that circle is actually the surface area of the outside of it.
What?
Now,
I get how you do, but I just don't get how it is that.
now the answer is pi is strange, and
Pi is strange.
it does all these weird things, and this is one of the weird things it does. That's the best explanation I can give you. Yeah.
I don't understand, like you have a sphere, but then how do you get the 2D circle?
Oh, because we know the diameter, therefore we know the radius.
Oh,
Right?
yeah.
Right. So, okay, let's back up a little bit. So we can get the surface area of this because we know the diameter and we know the radius. So we know it's the radius squared times, and then for a purpose, times pi, which we're just saying is 3 here. Right. So you can think of it as 3 times the 4 square, or 4 squares. There you go. 4 square centimeters, right? So this being r squared, this being our pi, right? And then just the number to plug in, just the rule to memorize is, for a sphere, it's 4 times that. Yes.
So why is there 4 now then?
Why is there 4? Because that's the rule.
4 is the magic number.
4 is the magic number in this rule. Just the rule is it's 4 times pi times the radius squared will get you. So this formula, if you choose to remember it, will always make it so you can figure out the surface area of a sphere.
Wait,
But a way to think of it is that you are doing 4 times this kind of imaginary flat circle at the center of the sphere.
I understand it. I was just wondering why there's 4. Wait.
Why is it a 4?
Yeah, I don't
Basically just because that is the formula, and pi is super weird, and all these rules just
Wait.
pop up that work.
Wait, I've been writing a lot here. Let's just wait. I'm pretty sure 4 is the magic number because 4 is the ratio of a circle to a square if they have the same diameter. No, pi to 4 is okay. Never mind. That'd be hard to. I'm pretty sure that's why. Never mind.
Okay.
Pi to 4 is the ratio of a circle to inside a square where the circle has the same diameter as the.
Yes. Okay. So basically, what he's saying. Okay. I think this is gonna get us into the weeds, but I totally get what you're saying. But if I throw that up there, it's gonna kind of derail us a little bit. Okay. But yeah. So I mean, yes, that's brilliant, but it's gonna cause people's heads to explode. So I'm gonna move on to the example here. Yeah.
So is it just 4 because that's just the rule?
For the sake of this class, yeah. That's as far as I understand it myself, honestly. Okay. That essentially the hardest thing about this particular lesson is that you have a formula to remember. That's the formula. If you want to be able to get the surface area of a sphere, you need to memorize this formula. There are ways to look at this formula to where it kind of has a little bit of a better conceptualness to it. I think imagining that there's the 2-dimensional circle in the center of the sphere, and that you multiply that by 4, and you multiply the surface area of that by 4 is how you get the surface area. I think that's a good way to look at it, but you know, it's not necessary. You can just remember the formula. So just to finish this up, in our example, our sphere has a surface area of 48 square centimeters. All right, here's the actual example. So I'm gonna let you try to figure this out. I will put the formula up here. Okay, so now that you have gotten my super clear example there at the beginning there, now use that to plug yourself in to this using 3.14 as pi.
Okay.
Get the surface area. And this does, there are essentially different ways you can do this that all make sense. So, yeah, has a diameter of 6 centimeters. There are some shortcuts you could take. I can show you a couple of ways that people have thought of it. I'll give you a moment to figure out your own path to victory here. Have you found your path to victory?
Yeah. Wait, are we supposed to round it?
Oh yeah, round it to the nearest square. But the thing is, you need to get the exact, well, you know, the closest thing to 3.14 and just drop off the end. Basically, you get a decimal and just forget the end of the decimal.
You just write it without the decimal?
For the final answer, yes. Okay.
Mr. Fletcher?
Yes.
So first, let's say
And then.
But then you just round it because.
Yeah. Okay. You got your path to victory. Okie dokie. So yeah, and I'll lay out a few different ways you could go about this. Okay. So we can think of this. And then, of course, diameter is 6 centimeters. Alright, so it'd be... Okay, which of course... Whoops, yeah. Which of course would get you 9. I'm just going to erase this just to save space. So we can all agree that we could just say 9 square centimeters, right? Right. Now, someone showed this shortcut is, so that being said, now I can totally do this from left to right, right? So I could start with just doing 4 times 3.14 and then get the answer to that and then multiply that by 9 square centimeters to get me to the end, but remember, there's a thing called the commutative property of multiplication. I can actually rearrange these.
oh,
Right? So that could actually just get me to 36 square centimeters. Right? And then you could just figure out your way to the end there. Oops. Oops, what am I doing there? 24, 6 times 1, 8. Pardon me. Am I thinking? Then 18. And then 0. So that'll be a 4. What am I doing there? I'm a little tired here. Okay, 3 times 1 plus 1 will be 4. 9. Okay, and then so I'll bring out if you all that you'll get 4 0 3 just I'll just put it there, and then of course since there are 2 digits behind the behind there, then I would put my decimal there, but round it to the nearest centimeter, right? So I can just cross that off.
Just for fun fact.
Yes.
So if so like as you saw, you rounded it to 113, right?
Sure.
So actually, the real answer with 27, which is closer to 5, is actually it's actually closer to 14. Well, no, not really. So and it turns out to be something like 113.14285.
Plus 14285. Okay, well those still both round to 113. Yeah, they won't end up quite exactly, but yeah. Nice fun fact. Thank you. Thank you. Here, I'm gonna give you guys a couple of focus points while people might be wrapping up there. And okay, just one more, and it is a bit less flabbergasting than the rest of it. In fact, I would kind of like we've got things to do. I would kind of like to rush through it because I do want to let you do. We do need to finish that art. Okay.
What if you're already done with it? Matthew?
I don't think you're done with it because you haven't done a background for it yet, have you?
Oh, that.
Yeah, we're doing the background. Okay. All right. So we want to get the surface area of this. I bet you can do it. You go fast.
Oh, this is, okay.
I'm gonna let you get out ahead of me.
So,
Go. Surface area. Units are centimeters. I will do 3 deep breaths. That will let you get out ahead of me.
Mr. Patrick?
What?
Quick disclaimer, this is not tedious at all.
Huh?
This is not tedious at all.
Okay, well, I'm glad you feel. I'll assume you're not being sarcastic, and sure. Yes. Oh well, don't do that. Just you can check yourself with me. Okay, so by now people have probably gotten a few steps here. So I am putting my answers in square centimeters. So that would be 2. 2 times 1, 2 times 1, 2 times 1, 2 times 1. All right, so I'm going to add those together and put that out there as 8 square centimeters. And then a kind of a simple way to do the big sides there would be just do the square and then subtract the missing area out of it. Thought was kind of a better way to do it. So 4 times 4, 16. Okay. And then this is 2 by 2, so that's basically 16 minus 4. It gets you to 12 for this. Right. However, there's another one on the other side, isn't there? Right? So it's basically for these, it's 12 plus 12 is 24. Okay. And then the last thing we've got, I believe, unless I'm missing something totally obvious, is the bottom.
Oh my god.
Right? And that would just be 1 times 4. Oh no! You gotta forget that! Okay, here we'll make that green. Okay, so that's 1 times 4, and so then that would be 4 square centimeters. Should be 4. Nope, I've missed something. Oh, the back! I forgot the back. Silly.
Oh wait, surface area. I thought it was.
Yes. Oh, so we also have the back, which would be 4 times 1. So that's another 4.
I think it's 4.
Whoopsie doodle. Okay, well that makes a lot more sense. Okay. So I'm gonna go 4 times 3 is 12. 12 plus 8 is 20. Here, let's switch back to that. 20. Getting us to 40 square centimeters. Okay. Oh boy, we really need to work on that art. All right, I tell you what, and I'm gonna turn this off.